All right, so we're trying to find the molar mass of sodium phosphate. We've got to find the formula first. Sodium is an element, and we're going to put it together with a polyatomic ion. In fact, we know this is a polyatomic oxyanion because only polyatomic oxyanions have ATE or IT endings. Oxyanions means there's oxygen in the formula. Anion, the AN on ion means it's a negative ion. So it's a polyatomic, more than one element, oxygen's in the formula, and negative ion charge. Okay? So let's find the charge on a sodium. For that, we're going to go to the periodic table that has the oxidation numbers on it, and see sodium has a 1 plus charge. In fact, all of the elements in this first column, except for occasionally, rarely hydrogen, in fact, all have a 1 plus charge. All of the alkali metals have a 1 plus charge when they're in an ionic compound. So this is a 1 plus charge. And phosphate, we need to find the formula for. So you look on the common ions list, and search around, and phosphate's right here. Okay, PO4, 3 negative. And we have a 3 negative charge and a 1 plus charge. We need to have as many positive as negative charges. So we need 3 of these sodiums. And we put those together, and we have a formula then. We have Na subscript 3. This means I am bonding these 3 sodiums to this phosphate. That's what that subscript means. Okay? So now we know how many sodiums and phosphoruses and oxygens we have. So we're ready to do an not an atom inventory, but a calculation of molar mass. So I want you to list them vertically, much like we do with the atom inventory. But instead of counting elements on both sides of an equation at this point, we're going to count we're going to find the atomic masses of each of these elements, and then multiply by the subscripts to get the sum of all the masses of all the atoms in the formula. That is the definition that I've given you for molar mass. So we need to find our regular periodic table and find the atomic masses. And sodium is this big old long number starting with 22.98. Did you have a question? I heard a question over there somewhere. I heard something. Phosphorus is 30.973, 762, and oxygen is 15.9994. In the formula, I have 3 sodiums, so I'm going to multiply this by 3. 1 phosphorus multiplied by 1, and 4 oxygens multiplied by 4. Now, since the numbers I'm going to produce over here, I need to add vertically, get to add together, get the sum of them. So I want to be careful to get my numbers all lined up well. Keep the decimal places lined up. The kind of thing you learned in elementary school. Trying to turn on my calculator here. Got too many different kinds of calculators. So and you can see we have 2 empty slots right here. Reminding you from Unit 1, you can't put zeros over there in chemistry or the sciences because that would be lying about the precision of the measurement. And we don't want to lie about the precision of the measurement. So we want to add all of these up. And it's 163.943 0.0669. Because I have two digits on the right that result from unknown numbers, basically, unknown digits rather. Those are insignificant. You have to have the units. This is grams. Have to have the species. This is sodium phosphate. We're going to round that number off now we're going to get rid of those last two digits because we don't know what those would have been had we had digits in these two places. Since I have a 6 here, that's 5 or higher, we're going to round this 6 up to a 7. And that's the molar mass. But in this class, I also expect you to finish the equality statement because we're going to need that. In fact, we're going to need it in the next problem. This is number 1 here. And so the equality statement is that this is equal to 1 mole. That's the definition of what molar mass is. 1 mole of that species. Okay? It's the mass of 1 mole of that species. Okay? And so we're going to show that it's 1 mole of that species. Got it? Let's see how we're going to go about giving some points here.
What if it's really close to 160, but it's like off by a point or two? At 161?
I don't know how you got that. Well, I don't want to propagate the points I'm counting off here.
They got like everything right. They just instead of putting the 9 by the 68 up there, go up one more to the right. Instead of putting the 9, they put like a 0.
Oh, really? Yeah. Okay, so this got one thing wrong. Does everything else look right?
Yeah.
Okay, well, we're going to count 1 point off then for that. Okay, that was a math error. All right. But let's give each of these elements a point. Each of the atomic masses for each of the elements a point times 1, 3, 1, and 4 a point. And this is where you're going to count off that 1 point right there for the sum, for the not sum product. Okay, those. The unrounded answer with units and species, underlining, arrow, final answer units and species equals 1 mole sodium phosphate. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 points total. Okay? Then, the next question was to, using that molar mass above, find the number of moles of sodium phosphate and 5.25 grams of sodium phosphate. So 5.25 grams of sodium phosphate is our starting amount. And we always put starting amounts over 1, at least in this class, in the math we do in here. And then we're going to use this equality statement. That's why I require you to write an equality statement when you calculate molar mass in here. We're going to use this equality statement there to figure out how to construct the proper molar mass ratio. Okay? The conversion unit. We want to match starting units and species with the units and species we put down here. This side of the equality statement has the same units and species. This side of the equality statement has grams of sodium phosphate, matching grams of sodium phosphate in our starting amount. So we're going to put that number with that units and species on the bottom here. And then the other side of the equality statement goes on the top. Okay? And just to remind you, when I have a fraction like this, where what's on the top equals what's on the bottom, the value of this fraction is 1. Okay? So we're multiplying the original number by the number 1. But we're doing it in a way that changes how we're measuring it. We're not changing the amount. Does that make sense? Because if you multiply by 1, you just get the same answer, right? So we are multiplying by 1, we're just measuring it when we get done. We'll have it in units that are different than what we started with. Anybody confused by that? Okay. Hope you got it. Alright, so we're going to cancel everything we can cancel. If it's on the top here and on the bottom here, we can cancel it. Both units and species. They can be canceled just like x's and y's in algebra. And we just do the math. So we're going to take this top number, multiplying by 1 or dividing by 1 just gives us the same answer. So we're going to pretty much ignore the 1s. Okay? Take this number and divide it by that number. That's all we have to do. So that's the numeric answer. We need to round this answer to the right number of significant digits. I'll do that in a minute. I want to first include the units and species that I still have left, because that tells me what that number applies to. Okay. Then I want to look at this is a division problem. In multiplication and division, the rule for significant digits in an answer is it must have the same number of digits as the measured or calculated number in the problem with the least digits. So this is a calculated number. We calculated it. So we know it's calculated. And it has 7 digits. This is a measured number. Somebody measured this mass. I made it up, but if we actually had that number, it would have been measured on a balance or something. We have 3 digits. So of the measured and calculated numbers, this one has the least digits, only 3. We want our final answer to have 3. Leading zeros are not significant, so these 2 are not significant. This is our first significant digit. This one, and this one are significant. Everything after that are insignificant, so we underline them. And then we draw an arrow and draw or write the rounded off answer. And it's always helpful if you'll put your final answer in a box so I can tell what that final answer is supposed to be. Especially for people who tend to have numbers and things written all over the place. It's hard to tell what the final answer should be. Okay? Alright, let's count up how we're going to give points for this. Measurement, units and species, all those are worth points. So are the cancellation of those 2 things. Putting it over 1's a point. Multiplying is a point. Number, unit, species is a point. All points. Number, unit, species are points. Cancellation and cancellation is a point. Equals. Unrounded answer. Rounded or underlined, the underlining of the insignificant digits, units and species, arrow, number, unit, species. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Wow, 24 points for both of them. How about that? That was just too easy, wasn't it? So for the whole thing, the whole homework is worth a total of 48 points, a maximum of 48 points. Okay, so on the top of your paper, you're going to put the number of points they earned in a box. The number of points they earned in each question, each problem should be in a circle out to the left of that problem. Okay? And then you need to make notes to them, explaining to them what they need to do to get it right the next time. Okay? Help them out. Be good to them. Okay?
Good.
Be good, yeah.